Hello! In this video, we're going to go over one of my old designs. If you're new here, I'm trying to build a motorized shoe to be used in virtual reality games. So the shoes will keep you in the same spot in the real world, but you can actually walk and walk infinitely in the virtual world. My current design I'm doing a build log for, and I'll leave a link to that in the description. But in this video, I'm going to go over one of my older designs, which is the one I'm holding here. So here's the old design. These are the wheels that when they turn, move the shoe forward and back. The way they are turned is by pulling on these strings. So you can see. So the motor would pull on these strings. And it's a double drum setup, which means that if this pulley is winding up, the string's winding around it, this pulley, the string is unwinding, and vice versa, depending on the way the motor is turning. And the reason it's in a double drum setup is, think about if there was a single drum and the motor just keeps turning and turning and turning and unwinds the pulley all the way, but then needs to wind it back up so that it can pull again. But it can't wind it back up if there's a single drum. So you have this double drum system where whenever one pulley is unwinding, the other is winding up. So the motor can continuously just pull to make the wheels turn, and then reset, and then pull, and then reset, which is the kind of motion that you would need for this omni-directional shoe. So if you think about when the user's walking, when they lift their foot up to take a step forward while their foot's in the air, the motor can unwind and wind these pulleys up as it needs to, so that there's enough string on the pulley so that when the user puts their foot down in front of them, the motor can turn and pull the wire and bring their foot back. Okay? And then the other thing is that this whole thing can turn like this. And I have a series of bearings here to make it so there's not a whole lot of friction, so that the string can go around all these different bends but still be pulled by the motor. So you can see, even at this orientation, it can still be pulled by the motor. The motor doesn't have to move. And then as long as when it's turning, the motor might be pulling these strings to keep everything taut, everything should work out. And that's pretty much the basics of how this works. Now, the reason I didn't go with this design, there were several reasons. One, it's kind of tall. You're kind of high up off the ground. I think this was about 2 inches, and then you'd have the leg attachment part on top of that, and then you'd have the thickness of your shoe. So it was a bit too thick, a bit too tall for what I really wanted to do. I thought it'd be a bit unstable. A lot of my old designs, I thought the shoe could be really tall, it would be fine, but then I realized, no, it's just too unstable if the shoe is tall. Another thing is that as these drums wind and unwind, the string does not wind perfectly on these. It'll get bunched up on one side, and sometimes it'll get so bunched up that it could that the string can come like over on this gear and then get caught in the gears. So I need some mechanism, kind of like a fishing reel, where if you imagine you're winding up a fishing reel, it has that part that makes sure that the string is wound evenly. I need something like that, but I don't think I can 3D print something this small like that could be this small. And then these bearings, these little tiny bearings, they're kind of expensive, and I don't think that they would be able to function under the load I would put them on. Remember, this string, the weight, the load that it's a whole person that is on this shoe. So there's going to be a lot of strain around all these bends, around all these bearings, and these little tiny ones I didn't think could hold up against the load, and they were kind of expensive too. And then even some of the parts, you can see, like this part, it broke a little bit. So some of these small parts might not have been able to handle the load. And I think that's pretty much it as to why I didn't go with this design. Maybe I'll come back to it someday and see if I can get it working. Oh, one other thing. There's a limit to how long the stride that you can have with these shoes, since you can only unwind the pulley so much. So if someone with a really long stride, or if I'd want to support being able to run, then you might run out of pulley and the shoe won't be able to bring you back all the way. So I wanted a different design that it could support any stride length. That was another thing. That's pretty much it. So let me know what you guys think of this, if you guys think it could work, if you have any suggestions about the troubles that I ran into. Oh, another thing I thought of. Sorry. If you can see that, where the string comes out of this bend, it would get caught, like between the plastic and the bearing. It would get caught in there, if you can imagine that. So that too was another problem that I ran into. So lots of little things with this design made it kind of hard. But like I said, I might come back to it. Okay, now I think that's it. That's it for this video. If you liked it, feel free to leave a like. If you want to see more of this content, feel free to subscribe. Any comments, feel free to leave them below. And until next time, thanks for watching.